The problem that we're going to try to explain in this video is the house robber problem. In this problem, a professional robber is explaining to rob houses. It's trying to rob houses along the street. Each house has a certain amount of money stashed. The only constraint stopping him from robbing each of them is that adjacent houses have security system connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given a list of non-negative integers representing the amount of money of each house, determine the maximum amount of money he can rob tonight without alerting the police. This problem can be cut down to two sub-problems of finding whether to rob from a house or not. But before we jump into the program, we're going to try to explain an example of this problem. Imagine there are four houses with money with a different quantity of money on each of them. The first house you can rob a value of 1, the second one you can rob a value of 2, in the third one you can rob a value of 3, and in the fourth one you can rob a value of 1. If you try to rob the houses 2 and 3, the alarm will go off and the problem would not be complete. If you try, the same would happen if you try to rob the houses number 1 and 2. So to try to rob the maximum amount of money possible, the robber here will try and rob the house number 1 and the house number 3, which would give him a value of 4, that is the maximum amount that he can rob. So how this program works is tries to create an extra space array to store the sub-problems. First, we try to eliminate some basic cases. If the length of the array is 0, it returns 0. If the length of the array is 1, it returns the first element of this array. If the length of the array is 2, it prints the maximum of the two elements that are in the array. So what we're trying to do is to update the dp in the position number 0 as an array in position number 0, and dp in position number 1 of the maximum of array in position number 0 and array in position number 1. Then we're going to try to traverse the array from the second element or second index to the end of the array. For every index, we update dp that in the position number I as maximum of dp in position number I minus 2 plus array I and dp in position I minus 1. This step defines the two cases. If an element is selected, then the previous element cannot be selected. And if an element is not selected, then the previous element can be selected. Then we finally print the value. As we saw in this example, we were going to try to find the maximum value possible to rob from the four houses. So when we run the program, it is going to give us the maximum loot value, that is number 4. That is what we tried to corroborate. This program works with something called dynamic programming, which is really important because having a clearer picture of dynamic programming can take our coding to the next level, because it is a technique that makes it possible to adaptively solve more really difficult problems, which is why it comes up in interviews or when you're asking for different jobs or homeworks. And it's using applications like machine learning, so it's really important to know about this kind of programming.